Welcome to Unusual Due Diligence. This fresh episode is about the Clover Health Assistant. My name is Poseidon, and I shall be your guide on today's discussion. Before we can answer what a Clover Assistant is, we first need to understand why a Clover Assistant is. How is the technology powering the Clover Assistant supporting the growing scale at an exponential rate? What are the forces pushing that scale? How is the Clover Assistant built? What is the stardust inside this technology that makes the intelligence tick? Also, when are we going to answer these questions? Right now. Let's talk about the future of personalized medicine by taking you to the zoo of critical problems you might not even know exist in the field. There are 5 buckets that we need to really understand when it comes to the problems that the Clover Assistant solves. The reason we need to do this is so we can together journey to combine our understanding of these different villainous problems into a cohesive whole. Sounds great. How do we do that? First, we need to just go deep enough into each of these problem areas to have a sense of what makes that problem tick, so to speak. Let's put them on display. Villain 1. Time. First up is the time-starved doctor. Let us turn to look at what is driving the problem of missing time. There are 3 key ideas leading to the time-starved doctor. First, there's a literal shortage occurring that is increasing as time goes on. The Association of American Medical Colleges, AAMC, projects a shortfall of between 37,800 and 124,000 doctors within the next 10 years. Maybe think twice before filming that Jackass spinoff. Second, there's a time component question. On average, doctors in the United States invest between 15 to 30 minutes per patient at a maximum. Why is that? Beyond the looming shortfall, there are forces at work, and one of those is just the law of numbers. Do you know the total number of patients a doctor has on average in the United States? The number might surprise you if not. According to the World Bank, as of 2017, the number of physicians per 1,000 people was 2.6. These are very busy people. But there's more. According to the AAMC 2020 report, 44% of active physicians in the United States, they're 55 or older. To make it clear, if 44% of the doctor population is 55 or older, what do you suppose happens in, say, 10 years? That is a physician shortage crisis in the making. We now have a good enough understanding of the 3 components that are contributing to the doctors being pressed for time, and these are factors that will be useful to know later in the video. To summarize then, there aren't enough, there's too many people, and the doctors we have now are rapidly approaching retirement age. Okay? Let's shift to the next villain in our lineup. This next villain is directly applicable to you and people in your life. The problem? Data. Specifically, healthcare data. Villain 2, spread data puzzle. The next villain is just a natural consequence of multiple years of technology evolution. Do you recall anyone in your life that bought a Microsoft Zune and entered in their workout schedule, and then a Fitbit, and then swapped over to that new smartwatch? Well, the healthcare industry was doing the same thing, only with everyone's health information over the last century. Data is spread everywhere, in inconvenient and tricky to extract places, such as from the clutches of expensive mainframes. Over the last 10 years, a concept emerged to try and sell the idea of an electronic medical record. Only one small catch. Every single company wanted their own version. So instead of any singular optimized medical or health record in a digital format, everyone, and this includes you, has one with every healthcare professional ever visited. Now, just as your smartphone has a multitude of apps that don't talk to each other, there's medical information across several apps and several companies you may not even know the name of that all contribute to solving the puzzle that is your personalized medicine. What have we figured out so far? Aging doctors, a significant percentage of which are approaching retirement age, are already in short supply and overcommitted to just managing an existing patient load. And then we have a complete information technology landscape littered with vendors, companies all scrambling to implement just a basic data input system. But wait, let's make this problem even harder. Villain 3. Chronic conditions. A patient is a person. A person has complex medical history, such that even if they are the healthiest and safest individual in the world, a person will minimally have multiple EHRs for a dentist and a primary care physician. Now, imagine for a moment that there are people who have complex medical histories. The unfortunate news is that not 1 or 2 people have a chronic condition, but that 130 million Americans have a chronic problem. That means anytime you see 3 people standing around somewhere, One of them has a chronic problem they can't talk to you about. It'd be easy to joke about this if it weren't so serious. Sometimes that means multiple people can't talk to you about their problems. What do I mean? Over 30% of the world population has five, yes, five health issues that require some level of management. This is according to a study reviewed by Science Daily. So to quickly recap, we have tax doctors working with disparate systems for patients with complex medical histories, and we're expecting results. Only wait, there's more. Villain 4, errors and omissions. What if 1 hour of every day in a clinical setting was spent committing data clerical errors related to the complex patient history across multiple electronic health records on behalf of an overworked doctor? 1 hour, you say? Where did that number come from? Good catch. It could be higher. According to the NIH, the data error rate has been found to be as high as 26.9%. Villain 5, information overload. The last villain is these information systems. This will be an easy one to follow. Doctors want to use data to make better decisions because as a doctor, there's not enough time to help control towards a positive outcome. However, a doctor is relying on disparate systems with possible gaps in the data and a complex medical history that no single human could ever hope to understand. Even Elon Musk has to hire people to help him build rockets to the moon. Oh, but wait, one more thing on this last villain is the delay in this arcane system. Sometimes it can take days or weeks for data to travel from one disparate system to the next, as results are computed and tallied on old computer systems from the classical era of the 1900s. Together, time, capacity, disorganization, errors, and overload make up our key problems that make up why the Clover Assistant was born. Enjoying the show? Click thumbs up. What Clover Assistant does. We've covered many of the specific challenges that Clover Assistant is looking to solve. So what does it do to overcome them? If you review the official documentation around Clover Assistant, you will quickly learn that the entire apparatus of the Clover Health Systems marketing engine is designed specifically to speak the language of PCP, that is, the language of primary care physicians. So I'll show you the outline of each of the areas and then we'll bring it all together. PCP chart. The first plank of the Clover Assistant is a necessary one. Is the doctor sheet that serves as the basic biomedical information about who the doctor is talking to. Think all the basics, and then add in a bit more as shown in these real-world examples from a wide range of places. Specialist charts. Remember when I said that 30% of the broad world population have up to 5 ailments? Those require specialized tracking. Instead of information entered just for your general practice, these are the doctors that specialize in a given area. It's where, say, the heart doctor centralizes all the vital information about the special muscle in the center of your chest. EMR, EHR. This is the big one, but on the surface this is going to sound kind of dry. Earlier I mentioned that it wasn't uncommon for one medical provider to have up to 16 different electronic medical record systems tracking information for one patient. Now just imagine how useful it'd be if there was a place that just merged all that into one. Pharmacy data. Getting that electronic medical record data in one place is only part of the story. If you're sick and see a doctor, there's a good chance the doctor is going to do what? Did you answer issue prescription? If so, you got this one right. Lab data. And if you ever have lab work done, we quickly learn that lab work is no longer done in one place. Instead, you have a little lab work done in a little bit of everywhere. For example, your blood work might not even be done in the same state you live in. Socioeconomic data. But wait, there's more. Having the charts from all the physicians that do the work on the person, plus all the electronic medical record data, the pharmacy data, the lab reports, you can start to understand how, when coupled with the problem we spoke about before, how that can be pretty potent. We're not done. There's 2 more important data feeds, and then we're going to combine it all into something amazing. Where you live, what you do for a job, and the kind of lifestyle you live, that all has important consequences for health. Let's use stark examples. Say you work in a coal mine. That person has a very distinctive healthcare need from the general population, and it's true for every profession. Everyone is, at the end of the day, just a little different. Evidence-based protocols. The last one is where we start to see something truly remarkable. Evidence-based protocols, or EBP, have 5 parts. Ask a question, find information or evidence to answer the question, critically appraise the information or evidence, integrate the appraised evidence with one's own clinical expertise and patient's preferences, and then evaluate. A patient participating in an evidence-based protocol is feeding into this system. However, prior to Clover Health, the patient was doing this in a disparate, disconnected, and non-real-time basis. And now we can combine all these parts and start to see the whole picture about what Clover Health is doing. PCP chart, specialist charts, EMR, EHR data, pharmacy data, lab data, socioeconomic data, evidence-based protocols, what it delivers, actionable data, potential issues, reminders, recommendations, and most importantly, progression. Hey, please click the thumbs up button. And if you enjoy this type of content, click the subscribe button too. Okay, so how does this work? How it works. Now that you've seen why Clover Assistant exists and what it can do, let's go into the magic of what is going on inside the Clover Assistant. Here's how we look under the hood. I'll tell you the process, and then rather than all of us watching me navigate hours worth of research, I'll summarize. Ready? Oh, wait, one more thing. The material I'm about to cover is all public. The links should all be in the video description below. What you'll find interesting is looking at the story of the technology stack, not the logical architecture diagram of how it all fits together. Our goal here is to simply illuminate the technology for one question. Can the technology scale to handle the problem domain? After all, we've covered the fairly tough challenge that Clover Health has set upon themselves to tackle. So let's look under the covers a bit and see what's inside. Here's how the process works. There are 3 steps. First, I go out and scour for all the job posting ads from Glassdoor to LinkedIn to other websites from before even Clover Health went public. Next, I trail around some personal blogs for engineers, their careers, any conferences, and other items that are hanging around. Last, I check for any public code, say in GitHub or other repos. Public code often has calls to APIs, and those APIs do things. Remember, the intent here isn't to reverse the secret sauce. Instead, it's to ask what technology are they using at Clover Health for the Clover Assistant to power the remarkable integration technology. You know, what are they doing? And what I found is quite interesting. You don't even need to be a Kung Fury time hacker to appreciate it. At Clover Health, there's a heavy reliance on Postgre. Postgre is a database technology that's sometimes pronounced Postgres. I prefer Postgre. The data teams primarily work in Python. If I had to bet, it would be to make use of extensive machine learning tools and capabilities and various packages available in that language. It'd be surprising if scikit-learn wasn't used for the developers in the house. Pandas for sure. AWS makes an appearance in multiple places, as does some mentions of on-premise hardware as well as Google Compute, GCP. However, in a large enterprise in the modern world, this isn't uncommon for a large company to simply have found themselves having a presence in multiple cloud providers, so that's expected. In the GitHub for Clover Health, we also see references to the Elasticsearch and other compute capabilities of AWS. Their IT positions talk about containers, virtual machines, and no doubt, depending on the networks they're deploying, it's a wide mix. Now, why do I think that? Remember when I said that most hospitals have a dozen or more electronic medical record systems? Clover Health taps into all of those and makes sense of that data. And this technology, admittedly a very short dive, is how that's done. So let's shift gears now and talk about why this technology matters. Oh wait, one more thing. We asked if the technology stack can scale. And in this model, the bottlenecks would be the database. How big can a Postgre database get? According to this quick Google search, this Postgre database is in excess of 75 terabytes. That's a lot of doctor's notes. Coupled with multiple cloud providers and a programming language well known for solving machine learning tasks, we can make a safe bet that Clover Health should be able to handle a double of growth year over year. If only we had proof of this. Oh wait, we do. If you're interested in me diving deeper in any aspect so far, say in the technology here and how it might fit together, or are curious about some aspect of, well, anything else, drop a comment below and I'll consider it for inclusion in the next video. In this video, we covered the reason why Clover Health created the Clover Assistant, the what of the integration aspects behind the technology, and even took a dive into some of the technology behind the scenes. Imagine another few years of continued exponential growth and aggregation of this form of technology and the opportunities that bring to all lives under care. It's a pretty exciting time to be alive. As for the unusual due diligence coverage on Clover Assistant, that's all we have time for today. If you enjoy this content, click subscribe and give me a thumbs up. Oh, stick around for a teaser trailer for the next video. Next time on Unusual Due Diligence. There's a new anchor being built to help companies build next-generation technology. We go find it.